Finally, the next one is the Deformation tab for setting deformation simulation conditions. At first, please save a project file. And to create a 3D surface mesh, click this model button. Based on the stack information entered by previous tabs, a 3D surface mesh structure is immediately shown. In this way, users can utilize this program more conveniently because it is very easy to define the simulation conditions by looking at the structure directly. The next one is Viewer option. You can move the structure with the mouse or change the viewpoint using these icons at the bottom. By zone control, you can check the layer name, thickness, and turn on and off the shade and mesh. Now let's set the analysis and boundary conditions used for deformation in the property. Let's start with the simulation condition. Right now, the calculation with the linear equation is possible. Deformation analysis is performed by a linear equation in which the displacement according to the force increases linearly. Analysis of non-linear equation will be added later. In initial stress, select whether to consider the initial stress condition. It means that stress remains in a material after original cause of the stresses, such as temperature gradients, has been removed. So when you know about the initial stress of a layer, please input here and then click Yes. The next one is temperature. Select whether to analyze the structure deformation related to the thermal changes. Also, after entering the coefficient of thermal expansion value in the zone condition and delta T value from the corresponding item, you can check the results according to the calculated strain. Mesh condition selects the period for performing the structure deformation. There are unstructured and layered. If you select layered, layered mesh and remeshing items are added. I will talk about this part in detail. As shown in the following figure, if you select layered, deformation is performed as a layered mesh. And then, select the method for mesh file output through remeshing. In case of yes, it is converted to an unstructured mesh file. And in case of no, a layered mesh file is output as it is without regenerating the mesh. And if you select unstructured, it means that deformation is performed as an unstructured mesh. What is the difference between the two meshes? As you can see, for unstructured mesh, the number of nodes and elements is lower than layered mesh. Therefore, I recommend to use the mesh as unstructured type. However, sometimes the calculation may occur divergence. In that case, please utilize the layered mesh. In addition, depending on the simulation cases, the selection for used mesh should be different. By our simulation data results, it is recommended to select the layered method for a simple structure without a pattern or a bendable structure. And for a relatively complex structure, using the unstructured mesh is effective. In the mesh condition, there is another function which is called type. As shown in the following figure, the number of nodes used in the calculation is selected from 4 or 10. Although the consistency of TH10 is very high, the calculation speed may be very slow. Therefore, I usually recommend to use TH4. Next is target type. It is convenient to recognize the target type and loads as a pair. For activation, there are 3 types: no, displacement, and radius of curvature. When entering pressure conditions only, please select no. In this case, you can enter the pressure condition in the loads. Actually, even when displacement and radius of curvature are selected, the initial pressure condition should be defined unconditionally in the loads as well. In the case of displacement, if there is even one node that satisfied the set displacement value, the simulation ends. Radius of curvature is selected when setting the radius of curvature condition. I will tell you the method to set the pressure condition. At first, please click this plus button and then select from surface, plane, or zone. Multiple selections are also possible. For example, for a surface, after double-clicking the specific polygon to which you want to apply the pressure condition, that polygon number will be automatically written. Plane is used when applying pressure in these 6 plane directions: plus, minus, xy, plus, minus, yz, plus, minus, xz. When you click Zone, the layers defined in the Stack tab are displayed as a list. It is used when you want to input pressure conditions for a specific layer. After that, just input the pressure for X, Y, or Z direction. The next one is boundary conditions. To set the boundary condition is very similar with setting the loads condition. At first, click this plus button and select the type for boundary condition. There are 5 types: displacement, symmetry X, Y, Z, and fixed. Actually, there is a displacement in target type. The function name is the same, but meanings are different. Like this figure, all nodes are moved by the displacement value in boundary conditions. The displacement value at that time are entered as ux, uy, or uz. Please note that the difference in concept from target type displacement. Fixed is fixed for all directions, and symmetry x, y, z is only fixed for each direction. For example, symmetry x means that it is fixed for the x-axis and free for the y and z axis. Surface, plane, and drawn are the same as loads condition.